So, hi everyone. I'm so happy to be here, actually. And I'm very glad that they presented me already as a TV star. I'm going to talk a little bit about me while you get all seated and the reason why I'm here. And this is a little bit scary for me. I don't know if it's the most suitable word for this. But I come from artificial intelligence field, and since 2014 that I started doing research in AI, a lot has changed. And in the last 2 years, there are things that have happened related with putting artificial intelligence, cool stuff, models in production environments. And that's why I found that I needed to learn a little bit about the DevOps culture. Okay, I'm going to just enter my password because I just saw that. Let me check that everything is working. Okay, there we go. So my point here is, or the challenge that I have, is that I have a full auditorium here. How many of you refer yourself as DevOps? Can you raise your hand? Oh, come on, it's called DevOps Barcelona. Like, what is happening here? How many of you refer yourself as backend developers? Okay. So are you front-ends or what else? Okay, so the thing is that I'm pretty sure that most of you have done software development, either websites, APIs, or whatever you needed over your career. But when you work on artificial intelligence, and this is a field that has arrived to companies barely 4 or 5 years ago, it is really hard to explain some concepts because artificial intelligence development doesn't work exactly as software development usually works. Okay, so that's the point that I want to explain today here. So what I learned from these 2 years working at Singular, where we have a huge data and artificial intelligence team, I run the projects that are related to artificial intelligence, so mainly computer vision, natural language processing, and some related with prediction and recommendation systems. And what were the challenges that I faced as a data scientist or machine learning engineer that wanted to put our models in production? Besides that, I do a lot of things, a lot of speaking, as today, but also I participate into a TV program called Orbital IKEA for those who are not from Spain. This is a really cool program in the TV about science and technology, and this is the first time that they host a technology section. So I'm also happy to be the collaborator on that. But moving on the data scientist work, so what you usually do, and this is just to put everyone on the same context, okay? What you usually do when you're a data scientist is dealing with data, okay? That was obvious. So traditionally, we were working with tabular data, which means your Excel files, tables in general, okay? Either with numbers, either with categories, but we have that. And that was very easy to work with because you have, and you may know that, you have a structure. You have a repetitive structure. In this case, it has columns and rows. But what happens when you want to work with images, when you want to work with video, or you want to work with audio or documents? Those are non-structured information. But it contains a lot of information if we are able to process that. So what has happened in artificial intelligence is that in the last years, we have had the ability, because of cloud computing, because of a lot of resources, frameworks that have arisen, we have the chance to work faster with this kind of data. So that's one of the reasons why today we are able to talk about machine learning operations, because we now have the need of not only working with tabular data, but mixing all the data that are hosted under your organizations, either if they are private or public. We need to understand how the customer works around the website, around an e-commerce, or whatever, okay? So when I work as a data scientist, what I want to explore is your data sources. You have heard a lot about datasets, I'm pretty sure of that. But then comes the hard work, and the hard work is how do you put that data clean. So if I want to work with images, maybe I have to turn them into matrices, or maybe I have to label them to understand what I'm seeing and how to compare them in order to train, to learn. If I work with text, maybe I need to categorize. Maybe I need to split the text into some kind of paragraphs or words. But there is always something that I need to do before I get to the learning phase. And when I arrive to the learning phase, usually the diagram that we used to depict was like this. So the machine learning life cycle, it's usually starting when you have a training set, which means that you have previously cleaned your data and labeled your data. You may have a validation set. This is optional. But for sure, you will have a test set. So training set aims you to learn. Test set is like your exam, where you face your model against new data, okay? And you analyze if it has learned or not. The process where we put everything together is the algorithm. And the algorithm, and you may have heard a lot of these words, is now really trending deep learning, but it used to be machine learning. It depends on how big is your training, how big you want your model to be, and how big your task or complicated is, okay? So let's say that we have a data set. I have picked an AI model, let's say a deep learning model, neural networks, okay? And I run my training. When I run my training, I get a model. The model is some kind of a zip file that contains information about the parameters that have been set in order to say, hey, when I get this data, I know that this is the best configuration, okay? But let's call it like a zip file with information. So I get that model, and I get some evaluation metrics. So what happens is that it doesn't work if I just run it once. So if you remember when you were little, you were learning through repetition. So your parents or your relatives were saying, hey, this is an orange. Hey, this is a person. Hey, you need to say goodbye, or you need to say hello when you see someone, right? So the neural networks are kind of the same thing. And it requires to going over and over through this cycle. So this is the key part on why artificial intelligence development is not the same as a software classic life cycle, okay, in development. So the thing is that this discipline, the data science discipline, comes from the academia, universities, this kind of environments. And it comes from that because the way we think or we get the approach of the problems is with this trial and error. So we need to put an hypothesis about the data that I was given. I need to say, hey, will I be able to learn, I don't know, to distinguish between cats and dogs? Probably that's an easy task, but what if I say, would it be able to distinguish between, I don't know, 20 different cats or types of cats? Hard, okay? So there are tasks that are harder than others, and that's why this is really getting into this scientific method. And what you are going to face in your team, if you work with data scientists or data engineers, is that they are quite analysts that they have to develop their models. Okay, so in our day-to-day work, you can start from, I don't know, working for some retail, but then you switch into some animal stuff, or you switch into audiovisual stuff, and you need to understand the context in order to work with the data. So that's why. So when I have my AI model, and let's say that everything works perfect, what's next? So usually what used to happen is that we train a model. Maybe some will publish a paper with that model. Maybe some others will run into a competition, like international competition of academics. But what if we are in industry? So usually what happens is that you have a notebook. Do you know the Jupyter notebooks or Google Colab? OK. So it is a platform that is some kind of interactive. But behind that, it's just a Python environment, more friendly to just interact with. Okay? So the notebooks became pretty famous in the data scientist world because they allow data scientists to just interact and interchange between text and code. And that's pretty useful when you have to write about the insights that you found, about experiments that you want to launch. Okay? So that's why they were really into the notebook style. The thing is that when you have an AI model, the notebook is not a piece of software, or at least it's not complete. So that's when you teach us how the software development should be done. Okay? So when I have an AI model, what's next? There was a paper published back in 2015, and it was called like this: Hidden Technical Debt in Machine Learning Systems. So what happened is that this diagram became really popular because people at companies, mostly led by Andrew Ng and some others at Google, said, OK, this is our current problem. We are working on the black box that is called ML code, but what about the rest? So what if I have to configure some machine that runs the AI model? How can I perform this data collection automatically? How can I serve the model so that anyone here can interact with the model and can see their predictions? How can I log everything that comes from those interactions? How can I retrain the model after that with all that information? So a lot of questions arise, and we realized back in 2015 that we were not ready. So that's why today, in 2022, we are talking a lot about machine learning operations and why we need people that come from the software development side, either backends, frontends, or DevOps, to join us in our teams, because we need somehow to collaborate with each other to understand how we can do our AI models more robust and ready for production. Machine learning operations, it really comes from the DevOps culture. Okay? So in DevOps, you have this cycle of development and then this other cycle of operations. So here, just imagine that the development part divides into two. So we have this design first, where we need to explore our data, we need to design our environment, we need to think the use cases that we are going to solve with that model. So that's the first part. Then comes the model development. So how do we learn? How do we train the model so that it learns from this data? But also, if I need to do some data engineer so that I need to, I don't know, create some data pipelines where data comes in raw and goes out clean and then goes into my model. That's also a part of the model development. And then we also have model testing and validation. So what I was saying, when you get a model, you get this kind of a zip file with information, but also you have some metrics, and you need to compare how the model is learning. We have some specific metrics for each kind of data or type of data that we use, or kind of common use cases. So we are able to decide which metrics works best for each scenario. And then comes the software development work. Okay, so what I was talking about in the first part of the talk was about the design and model development. But now, what happens when we include operations, when I want to serve my model so people can use it? So I have this model deployment. I have the CI/CD pipelines, and I have the model and triggering. And that's pretty much everything you've heard of for, I don't know, how many years in the DevOps software development culture. Okay, so we're cool, because we start to talk about the same things, same concepts, but just applied to machine learning development. So I'm pretty sure that you know about continuous integration and delivery, but just in case, so continuous integrations needs to think now in the data world about testing and validating code and components. That's cool, we all know that, but also validating data and data schemas. What if I expect some picture in my pipeline, but someone introduced a number, okay? What if they sent an image, but it was not high quality, or at least not the kind of image that I was expecting to? So we face into these issues when we put the models in production, and there are no technical profiles such as, I don't know, quality assurance, but related with data, okay? So everything is quite new here. And there is a lot of space in collaboration and into merging our knowledge from teams, from different teams or capabilities. So there's continuous integration on that. Then continuous delivery. So what happens when I want to put this in production? So I have to package all my software. But I know that this is a cycle that repeats itself. So the model, it's a living thing. So I need to monitor it. I need to see how the service is going. I need to see the logs. Okay, so that's about continuous delivery. And then what about the training? I was saying that the key part of making an AI model to work 24/7, okay, is to do continuous training. Why? Because when I work in my environment, that's kind of a laboratory environment. But if I want all of you to use my model, probably you are going to introduce things in a different way. You are going to get different predictions. Some will work, some others won't. And probably what will happen is that my model will start to work bad, because a lot of new things have been input to the model, and I need to reorganize everything again. So continuous training is all about that. It's about allowing a piece of software to retrain itself, to go again into this point when we had this algorithm that runs again for a number of iterations, and that produces a new version. And if it produces a new version, I need also to deliver that new version. And that's pretty similar to what we've been doing with CI/CD pipelines, actually. The thing is that we need to find a way to do it, I don't know, friendly, or at least in a feasible manner. And again, there is not a lot of documentation about that. So if there are not a lot of experiences related with this, how can we accelerate our AI in production? So I have divided this part into 3 levels. It is all about my experience. It is all about also the Google documentation that is out there related with the MLOps culture. So usually the point where you start, or when you face yourself into this point of, OK, I need to show something to a client that contains an AI model, the client wants to interact with that AI model, probably you are facing to this diagram. So you have prepared data extraction and analysis notebook or whatever. You create your manual experiment steps. So this is all that I have previously talked about. So this part of the labeling data, cleaning the data, then training, and so on. So you get a trained model. I'm on the purple box. When you have a trained model, you want to serve the model. And I'm going to speak a lot about this part. So the complicated part starts at that moment. For you, probably it's easy. Hey, I will just put a website, and then the model is stored there, and then we have some API. That's it. You can start by doing just that. So the first level is, how do I create a simple prediction service for my model? And usually what data scientist people doesn't know that well is that once you have a model, you can do just a website to show your model, just to interact, just to check if it works. And you can create, I don't know, some ngrok tunnel or something so that you can show it from external PC. So there are a lot of libraries that will help you with this in case your data scientists aren't used to do these kind of things. And I'm saying this because I have seen how people come from statistics or mathematicians or physics and just joins into the data world, and they don't know maybe what is an API, but they are really good in doing data scientist stuff. So this is a pretty friendly way to just show with Python that you can create a simple front end that will also run a small backend as a service, and you will have your model out there. So the example that I'm bringing here is Streamlit, and there is also another one that is called Hugging Face Spaces. So these are, right now, the most well-known libraries to perform these kind of tasks in case you don't know how to deal with a front end quickly or how to deal with an API and these kind of things. So these two things, these two libraries, will allow you to create that demo of your AI model. And these are pretty simple to use. If you want to host it in their own spaces, Hugging Face has their own website. They acquired Gradio to do that. So they right now have these Python machines that just put up and your model is working, pretty easy. And then you have a Streamlit that connects also to GitHub or some other repositories, and you can just run a machine from that if you host it under the Streamlit cloud. But you can also host it under your Google Cloud environments, AWS, or whatever you prefer. It's really easy, and it takes just, I don't know, an afternoon to learn how to deal with these components, okay? I have brought an example so that you can get, well, at least an idea of what I'm telling you. So this is a real case where we wanted to do a POC, a demo about anonymization. So just perform anonymization in text. And usually, I mean, yes, I can do a lot of documentation and just pass documents and documents to the model and to show the results. But if clients or people interested can play with it, it's a lot more fun. So this is the result of using Streamlit. It is a common front end, and it works just as a website. So behind that, it just runs Python code. And another example will be this thing. I don't know if you have heard about Stable Diffusion, DALL-E 2, and all these cool AI generative image stuff that is out there. But if by any chance you have run into this portal, the Hugging Face Spaces, what you are really running is a simple pipeline that just launches the demo once you enter an image, okay? And everything runs into Python code. So this has been done using Stable Diffusion code plus the Gradio platform inside Hugging Face. And believe me that this is quite easy for your data scientists, also because these spaces, these environments, for instance, Hugging Face, had become like a model hub. So a lot of data scientists know about this kind of web page, and it's really simple for them to just plug and play and try to say, hey, so your delivery is not going to be a notebook anymore, but we are going to try and to get into this Gradio level or Streamlit level where you can just build your own front end and to see how to do that. The level 2 will be model registry and model tracking. So when we were talking about continuous training, which is this third part of the MLOps, one of the things that happens is that we are used to run a lot of training life cycles, okay? So because I need to change maybe some parameters, maybe some data that is new that I didn't have in mind at the beginning of my experiments. So again, that's why I was saying that this is really like a scientific job, so, or like a job in academia. So when I have these kind of platforms like MLflow, what I offer to my data scientists is a central repository where everyone can just connect to log their experiments, okay? So just imagine that you are a team of people. Some of your team are working on AI models, and they need to keep the track of which parameter did I choose, which data did I choose. Did I put the new data that the client sent me to, or have I changed, I don't know, 10 times this parameter? I don't remember exactly how I did the setup configuration. So this kind of software, it's just a Python library, allows you to put up a little environment. It's a front end with some databases on the backend side, and will allow you to track everything that you do in your code just by putting some logging commands in a Python format, and will allow you to send everything to your tracking server so that you also can get more friendly with all these metrics and all these experiments, and you are able to analyze what your data scientists are doing and what they are producing. And the cool thing about MLflow is that they also allow you to create a model registry. So the model registry allows you to store all these model zip files and also to version them. So this is as when we have a GitHub repository where I have my code, and I know this is the development, this is the production stage. So I can do the same with my models. And this is quite cool for a data scientist to learn how do we produce software. And I'm talking as a computer engineer here. So the cool thing, again, is that you can connect both. So you have the MLflow tracking server, you have the model registry, and then you can start automating things, because that's natural. When you have this stuff, you start wondering, what if I automate the way I log things into MLflow? Or what if I automate the way I generate the new Streamlit version? And that makes everything easy or easier for everyone working on an AI project. So this is kind of the look and feel of MLflow. It's quite simple, actually. So there is a sidebar that you cannot see here that contains all your experiments. You can create your own IDs and everything you want. And then you have this main view where you have just a table so that you can filter as you wish. And you have your ML versions. This is the model registry. You have the metrics for each of your models and the parameters. The parameters are really important for data scientists, okay? And there is a level 3, which is the most complicated one. And actually, this is the one that we are facing right now, and it's quite difficult because it's the one that most of us hasn't performed, like, never. So once I have my model registry, once I have all these tools that I provide for my data scientist team in order to work faster and also to enhance traceability, so I get to this point where my client wants to put everything to production, but also to scale, okay? And that means that a lot of things need to be stored in order to do that automatically, okay? So I'm talking about automating everything. So there are like 6 tasks that I have here. Some of them will come from the previous stages. So the first one is the development and experimentation. So if you see the diagram, it's more or less what we have talked before in the talk. So what I have new is that I will need some kind of repository in order to store there and version my code, okay? So once I have that, I can create my CI pipeline. You all know how to do that. You can create your own using your favorite YAML-based software. And you can just package your software, okay? So you package your software, and then you create the continuous delivery pipeline. And that's the same thing that you have done always. So number 4 and 5 are a little bit tricky, because it will depend on which thing you use to register your model version. Let's assume that we are using MLflow, so we will have some software or piece of software that will be connected to my production environment to gather all the metrics, to log everything that comes from there. But we could have, I don't know, some Grafana or something that better suits your use case. It will depend. And we are able to train the model, OK? So once we train the model, we get into this new huge pipeline where I want to automate the training. Okay, the continuous training is actually this whole pipeline. So what is happening here is that if you observe, this part is basically what I was telling you at the beginning of the talk, when we had this diagram of the data labeling, then the data sets, and then we were training and obtaining the model. But I want to do this automatically and as fast as possible, okay? So this goes also into the continuous delivery model serving pipeline, because if I want to generate a new version of the model, I need to be able to execute this automatically, okay? Because I want to put it on my website. And then I create my prediction service. And my prediction service needs to be also connected to my logging system. Okay, so again, here we can separate and say, let's use some other logging software, or let's still using MLflow, whatever you want. But we need to gather also some performance monitoring metrics. And you know more than me in here. Because let's say, what about the latency? What about the seconds that, or the milliseconds that the client starts looking at the window for the model to say something, okay? So there are a lot of logs here that comes from the DevOps and classical software development that can be included here, and they are quite useful in order to continue working. And then you see in the middle this metadata store. So this is all about useful metadata that gives you a glimpse of what happened during all these predictions. So if I get, I don't know, 200 of you to interact with a model, I probably want to know which kind of data did you upload, if I can, of course, which kind or at which time you were just doing the prediction, or at which time did you just get the output so that I can compute this model latency. Everything that is useful can be stored here at this moment, and can be used also to give more information to the model training pipeline, okay? And then, of course, you have a trigger that runs everything again and again and again and again. So if we summarize that, because, of course, this is, as I was saying, more difficult. In a diagram, it's simple, but when you try to implement, it's difficult. It's kind of a state machine. So if you're familiar with a state machine, it's rarely what you are seeing here. Okay? All these diagrams are in this website of MLOps.org. So you have your source code, you have your pipelines, and then the pipelines are packaged. You automate your pipelines, you train your model, and you create a prediction service. More or less, kind of the same thing. Okay? You go from one stage to the next one. So how can we do it without doing it from scratch? And this is the cool thing. So there are a couple of ideas here. The first one that I knew about was Kubeflow, which is also related to this MLOps page, because it's like the open source version of an MLOps service. So if you use Kubeflow, you are able to set up kind of this diagram with effort, with time, but you are able to do it. And now there are some other versions that are just cloud-based that can also run these kind of pipelines, but also require, of course, some time to adapt. So if you want to dive into the whole thing, I'd recommend to use Kubeflow. I don't know anything about Kubernetes, so just skip your questions about that. but it's quite cool. I mean, because it has now a lot of also connectors to frameworks that are really useful for us. So this is quite cool to start, but if you have the chance, I also know the alternative in GCP. The same team that was developing Kubeflow was a Google team, so they are creating like their own version, and they are calling it Vertex AI, and this is cloud-based, so you can just put the service up with a bit of effort, but you are able to run this MLOps service. The moment that we are living right now is this thing of I want to explore a little bit what MLOps is about, but also we feel a little bit of maybe we are over-engineering. So, and I want to be honest here, so there's no need to implement MLOps for every AI project that is out there, but in the recent years, 2023, 2024, will become, I'm pretty sure, a trend, because it is a need. There is a need. There is a need. There is an evidence that without this, it's really hard to run AI models. And the artificial intelligence field is getting older. So it's gaining more maturity. And that also means that we will need more robust software to help all these models to run properly. So your data scientists will be mainly focusing, if we are assuming that we are using either Kubeflow or Vertex AI, into this part. So there are a lot of services that they can just plug in, such as the Vizier optimization, which is just to train your models faster. There are also like this yellow box that has AutoML pipelines. So that means that if your use case is kind of a famous case, like object detection or something like that, or classification of images, probably you can just run one of these, and will work quite cool for a prototype. But it will allow you to explore the rest of the things. Okay, so maybe that's a good first step. What I'm saying is that if the opportunity comes to you, just don't be afraid. Everything or everyone that are working in AI models in production are facing the same issues. And it's the moment to talk and to collaborate. So one of the cool things that I want to finish my talk with is about model cars. So model cars are being one of the greatest experiments that are happening in AI teams. So basically, data scientists, again, when they were having these AI models, I was saying maybe some of them published a paper, maybe some of them upload the code to GitHub or something. But now, because everyone wants to use AI, and AI is breaking a lot of barriers in a lot of sectors, there's a need to tell how my AI model work. Because a lot of things that I have heard from people working in software development that may have never worked with a data scientist before is, I don't understand these people talking about data, like metrics, like training, whatever. I don't understand. This is like a black box, okay? So the model cars arrived into a great moment because it is like a README. It's like a README file, but it's written from the data scientist part, and it usually contains these kind of sections. If you go into the Hugging Face spaces or in GitHub, wherever there is code or demos about machine learning, they are starting to use these kind of things. So what you will find is some kind of instructions, basic instructions on what the model does, how it has been trained, how it can be deployed. And this is really cool, because it's just language, so either Spanish, English, whatever. It's not code, and we can all contribute into that. So this doesn't mean that not only, the data scientists need to write about this, also the rest of the team, so the software developers, need to understand what it's being putting out there, because it's also their work. And probably they can start to contribute somehow. So what I'm saying is that there are new things coming in There is a lot of NI explainability, interpretability of models. There is also this part of the privacy, data privacy, what is going to happen with that. And there are a lot of course, backend responsibilities, data architecture responsibilities into that. So just give yourself a time into discovering this whole new world. My main conclusions for this is that data scientists and data engineers cannot work alone anymore. I'm pretty much against teams that are just data whatever. I think we need to mix. And I mean, at the first time it's hard, but people start to understand each other once you leave them for a month together. MLOps is still a work in progress, so everyone can contribute at this point, either by trying this solution, either by contributing to open source versions such as Kubeflow. But there's a need, as I was saying, there's a need to move AI models into production, and there is a lot of work coming for you guys. So just doesn't say that you didn't heard about this. We will see in a few years if I got it wrong. As I was saying, if your data scientist doesn't know how to work, just try to explain them that there are a few solutions, simple for them, either Streamlit, Hugging Face, and some others that you may know or you may find, and try to facilitate things to them. If they are being stuck with experiments, just say to them, hey, there are software or libraries that may help you with this. I have talked about MLflow. There are others like DBZ. So you can find this kind of software for your data scientists, because they may not just think that someone did a job for them out there. And the whole experience, as I was saying, includes continuous delivery, continuous integration, and continuous training, and that involves a lot of people. So again, thanks. If you have any questions, I'm happy to answer them. And be kind. I'm not a DevOps. Thanks.
Yeah, we also have a number of them, so let's see. I'm going to try to group them, and please bear with me because this is not my main topic, so if I say something stupid, Nerea will correct me at some point. Okay, so let's try to group them. In terms of alternatives, right? People are asking if you tried AWS SageMaker. Mm-hmm. Can you talk if you did, and how that compares to the tools you described here?
Yes, actually, AWS SageMaker works quite fine as well. I have tried actually more SageMaker than the GCP versions. Mm-hmm. But my experience is that all these services, the cloud-based services, as they are seeing this need, they are putting more focus on this kind of pipelines that we may not see from the beginning. So it's a good starting point. So what I'm saying is that maybe if you got the chance or your team of data scientists got the chance, show them SageMaker, not just the notebook part, but also how it creates the job, how it delivers the job. So this is a lot of, again, software development culture behind that.
Okay, so another question that's probably interesting for many. Well, hopefully. So they're asking, like, in terms of like storing the data set at the very beginning, you usually would go for a relational database, but there are alternatives like graph databases that may solve part of the model.
Yes.
What have you tried, like, or explored starting from a graph database and then fit the model from that?
You need to, look into it. It will depend on your use case. It will depend also on the knowledge of your data team. I'm really, so what I have used more is either non-relational, because maybe you have a lot of object information. Mm-hmm. So probably that works fine. You can also try and start with, I don't know, some relational database, but it might not work if you want to scale. And graph databases are now also being a trend into the biological sector because of AlphaFold and some other models that got out there. They work using graph neural networks that are a little bit similar of these graph databases. So again, if you have use cases about connecting things, probably graph database can work like Neo4j or whichever other.
Yeah. And now questions more about machine learning itself, right? So people are asking about, in terms of compliance, do you think it's always mandatory to have real data or like encrypt that? Or yeah, it's always the same, right? Like in every environment?
So
especially at the beginning of the model
right
evolution.
now, yes, I'm not a fan of over-engineering at first. So I'm a big fan of just doing some prototype. And that prototype at first might not have everything encrypted. But once you have these first conversations with your client, you get to the point where you have to explain to them, hey, here's sensible information. Hey, you might to hide this from, I don't know, public access, whatever. It will depend on also what I have faced is that it depends a lot on the data culture the client has. Because I work as a consultant, that's why I'm talking about clients like all the time. But what I have seen is that it depends so crazy in which is the level, this data maturity. I have faced teams where they were just testing and just playing with the first demos. And I have other clients that have a lot of things in production and are talking about data governance. So what I'm saying is just understand first which is the level of maturity that you have in front of you, and then suggest accordingly. Because if you start a conversation by saying, oh, you need some data governance here, I'm saying, like, they are not going to buy it, like, never. So you need to also have this patience with the people that you are, I don't know, showing your stuff.
Okay, so this one is about once you have the model running in production and has been, integrated with datasets, how do you like control or attack, let's say, a bad input, right? How do you like? Well, that's probably a bad terminology in terms of machine learning. So it's like, how do you stop bad actors from polluting the model with faulty inputs, and then the neural network gets corrupted in a way?
Yes, that's a cool one. There's no recipe for this, and I'm pretty sure this is going to be the point when a lot of teams are going to say, hey, maybe we need to, get into this DevOps securitization culture, because you never think, oh, my model is going to become so famous that it will get too much, people attention. But we've seen it with generative image models. They are now quite trendy. And one of the things is, how do you discard data when you are not receiving good data? So this is, so my recipe here is start with model quality analysis. So what I have done, and I have not done a lot about this, but I have started to work with quality assurance developers. So the idea is that they tell me how they work, I tell them how I work, and we try to analyze these kind of things that might happen. So we at least try to arise an alert or something where I can say, hey, something weird is happening here. And maybe if you have the chance, probably you have some security people or something around you that can help you with this kind of attacks.
So it would be like monitoring the output of the model in a way, like you would do in a server, let's say.
Monitoring is essential, so please monitor your things.
And last two very quickly. One is about teams organization. I guess that's a common one. Do you think it's better to have a dedicated MLOps team, have a DevOps integrated in the MLOps team, or like you've seen probably both approaches?
That's also a cool question. I'm such a big fan of just mixing. So if you don't mix people, people will not talk the same language, and that's quite obvious, but it happens. So in my experience, it has worked better when the DevOps was integrated into the team, even though it requires time. For both sides, but it works better.
And the last one, which is a bit of a joke, why do we call it artificial intelligence if it can still not pass the Turing test? And do you think one day, this will change?
That always comes out.
to close it.
I have to say that it has grown a lot. I mean, these years, artificial intelligence has grown like crazy, but still, I'm not answering that question because I don't know what will happen. But what I try to say to people is one of the things that we don't know how to do with artificial intelligence is multitasking. So humans, we are really good at multitasking. So either I can just handle this while I am talking to you and I'm just pointing to things. Artificial intelligence is not good at that. And if we are not reach first that level of performing multitasking with the same training, I'm not talking about different trainings, just same training to do multitask, it's really hard to reach the Turing level. So just think about that. Like, artificial intelligence is still a lot of work.
For sure. It will keep us entertained for a while. All right, thanks a lot, Nerea. It's been a pleasure to have you here. Thank you.